Hello, everyone. Good morning. Respected authors and invited guests, welcome to the technical session 7D. Myself, Gayatri Burguda, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from the 9th to the 11th of April 2026. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. Upon 9 minutes, I will raise a gentle reminder. And there is another request to all the participants that you all stay connected with us till the closing remarks. If you have any kind of queries or doubts, then you can write it to me in the chat box. And just before we start the session, I would like to introduce you all to the session chair for today's session. I'd like to welcome Professor Dr. Vishnu Kumar. He is an assistant professor in the Department of Industrial and Systems Engineering at Morgan State University, Baltimore, USA. With over 15 years of experience, he specializes in applying AI and machine learning to industrial and healthcare challenges. His research focuses on public health analytics, supply chain resilience, smart manufacturing and IoT, and engineering education, driving data informed and innovative solutions. I would like to welcome you, sir. Would you like to address the participants?
Yes. So hope you can hear me. So good morning, everybody. First of all, thank you so much for this invitation. I'm really happy to be the session chair. So I'm really looking forward to see all the presentations and research that everybody is doing. So good luck to everybody. Thank you.
Thank you so much, sir, for your motivational words. Next, I would like to introduce you all to our second session for this chair. Dr. Dushyant Singh B. Rathod is a professor and head of the department at Gandhinagar Institute of Technology, Ahmedabad, India. He brings over 11 years of teaching experience along with 4.2 years of industry experience. His research interests include artificial intelligence, machine learning, deep learning, data science, and IoT. Now, I would like to move on to our presentations, and I would like to call upon the first presenter for the day, Mr. Britt Christoph B. Montalvo, to present his paper titled A Governed Forecasting and Anomaly Detection Framework for Live Birth Planning and Provincial Health Systems. Sir, you may start presenting.
Hello, good morning. Can I share my screen for the presentation?
Yes, sure. You can start sharing.
Can you see my screen now, everyone?
Yes, it's visible. You can start now.
Okay. So, good morning, everyone. So, my name is Britt Christoph Montalvo from the Philippines, and today I'll be presenting my study entitled A Governed Forecasting and Anomaly Detection Framework for Live Birth Planning in Provincial Health Systems. So, first is this chart shows the per quarter data of a certain province, namely Surigao del Norte in the Philippines during the 2021 to 2025. But the problem is how it's being used. So, FHSI's data, this is the traditional data reporting in the Philippines for maternal health. So, FHSI's data has traditionally been used retrospectively. So, health managers only review it after the reporting period ends. And this means changes in birth rates, whether a sudden surge or a drop, are detected too late. By the time the data is analyzed, the window for timely action on staffing, logistics, and resources allocation has already been closed. So for this research, the three pillars you see here are the FHSIS, forecasting models, and public health dashboard, which all exist independently, but they don't work together. So FHSIS is locked in in retrospective reporting, forecasting models lack the deployment in governance that need to ensure the outputs are trustworthy. And dashboards don't incorporate anomaly detection so to flag critical changes. So this research gap is the absence of an integrated governance system that connects all three into something reliable and actionable. So our methodology follows the CRISP-DM framework, a structured interactive data mining framework as shown in the pipeline on the right. The process moves from CRISP-DM framework through a preparation phase model, competition, and an operational gate, anomaly identification, and finally a dashboard for stakeholders. So each stage feeds back into the others. So this isn't a one-time analysis. It's designed to be repeatable and operationally sustainable for provincial health planning. For the forecasting strategy, we tested our candidate models, namely ARIMA or SARIMA, ICTIS or Holt Winters, Profit, and the NAVE baseline. So the selection logic is strict and two-tiered. First, rolling origin. So cross-validation is used throughout to prevent data leakage and you ensure the results reflect throughout of the sample performance. Then the maze must be below 1, so meaning the model must outperform the naive forecast, which is the baseline. And models that fail this are eliminated immediately. So among those that pass, the one with the lowest SMAP is selected as the final model. For our anomaly detection, we use a robust Z-score method based on median absolute deviation. Seen in the formula on this slide, the key advantage of MAD over standard deviation is that it handles non-normal data and extreme shocks much better. So instead of comparing values against mean, it uses the median and dispersion, making it far more resistant to outliers. Anomalies are flagged automatically when the absolute Z-score exceeds a computed threshold with no manual adjustment, so preserving objectivity and reproducibility. So this slide shows the 4-model comparison, which against actual 2025 data quarterly of live births. So looking at these charts, the naive model is flat across all quarters. It clearly missed the actual variation. For ETS, it consistently overshot, especially in Q4, and ARIMA was more responsive but overestimated in Q2. Profit performed the best. Its forecast tracked the actual data most closely across all 4 quarters, producing the lowest total deviation of 255 compared to 1,154 result for the naive model. So this validates Profit as the superior model for this provincial level series. So there are 3 takeaways from this study. Is first, at the provincial level, the framework is highly reliable. So SMAP of 4.45 and MACE of 0.42, well within our deployment thresholds, making it ready for strategic planning. Second, at the municipal level, most LGUs do not be deployed due to low volume and intermittent data. Only in one municipality with stable data passed our strict gate, but this depends on the data per municipality. So third, and most importantly, the biggest takeaway is that the data science alone is not enough. We need strict governance, controlling when and how models are validated, deployed, and used. So that formula that I presented earlier, so the data science plus governance is what makes proactive health planning possible. So that would be all, everyone. Thank you.
Thank you for your presentation. Sir, do you have any questions?
Yes, thank you for the presentation. It was great. So I just have one quick question. So in this work, you are just looking at one province, or are you looking at multiple provinces?
For this, we are only testing one province, which is Surigao del Norte in the Philippines.
Okay. So then do you have any future plans of extending it to other provinces?
Yes. I'm planning to, or we are planning to integrate this to our neighboring provinces, and once the project is completed, we will proceed to the other regions as well.
Okay. Okay. Thank you.
Thank you for your presentation. Now I'd like to call upon our next presenter, Mr. Sriram Dange, to present his paper titled A Hybrid Wavelet CNN Vision Transformer Framework with Explainable AI for Medical Image Classification. Sir, you may please start presenting.
So I'm not sure if he is in the call today.
Yeah, I assume he's absent for now, so we can move on to our next presenter. Marin Jo's ma'am to present her paper titled AI-Powered Investment Assistant. Over to you, ma'am. You may start presenting.
Okay, am I audible?
Yes, ma'am, you're audible.
Okay, let me share my screen. Okay. We are introducing our paper AI-Powered Finance Assistant. In this paper, we are introducing an AI-based investment assistant that help the users to understand the basic fundamental principles in the financial marketing. Because the financial market data is increasing day by day, and the common people, other than the businesses and the market people, are not aware of the basic fundamentals of the financial market. So we are introducing our AI-powered finance assistant that help us to assist common people in order to understand various stock data that present in our market. It also act as a advertising part from the industrial perspective in order to give their advertisement for their specific stocks. So we got an opportunity to collaborate with a famous investment company called Franklin Templeton. We got their financial expertises, and we have combined our AI technologies and ML models and introduced our chatbot, AI powered finance assistant, that gives lots of that provides various prediction, visualization, and recommendation system for users. And one of our major objectives of our presentation is that it mainly uses user query input and processing. Mainly we are using users inputting a query. Mainly we are using LLM in order to split the query, in order to identify various tickers. And we are using various real-time market data from the finances in order to fetch various stock data. And we are also giving personalized stock suggestion on the user's goal, and we are also maintaining portfolio constraints and market news conditions. And we are also trying to implement the stock market comparison between multiple stocks. And we are also at last we are trying to visualize what we have done about the stock trends, about the portfolio, about the prediction analysis, etc., in a graphical form. And then at first, we are using a paper called Stock Market Prediction using LSTM. In our paper also, we are mainly using LSTM as a model, long short-term memory. It is mainly used for time series forecasting, and it helps us in historical stock data pre-processing, and also implement deep learning model to capture temporal dependencies. And for the next, as a part of our paper presentation, we are taking next paper as a review of text-based recommendation system. And in that, it is a paper written by S. Kanwal, S. Nawaz, M.K. Malik, and Z. Nawaz. And the famous methodologies that is introduced in this paper is various text mining technologies like TF, IDF, TF-IDF topic modeling, and for feature extraction. And we are also including various pre-trained LLM models for this presentation. And then in the next, we are using stock market prediction and visualization. They are mainly using machine learning based stock prediction and interactive visualization tool for visualizing charts and trends indicators. And then there are various products that are available in the market now. They are Magnify, Stock GPT, and FinChat. There are also there are various limitations in these products. It's like there is lack of personalization, lack of interaction, lack of real-time response, etc. We are trying to implement these limitations and overcome these limitations in our project. Yeah, there are also lack of real-time market data, lack of transparency, and inadequate risk assessment mechanism in all these devices that we have already mentioned, and we have tried to rectify this in our product. And this is a major system architecture. It has 4 layers. It has user interaction layer, application layer, data intelligence layer, and output layer. And in user interaction layer, where the user interacts with the system, we can give the queries into the system. A chatbot is visible, and mainly the front end is visible in the system in this layer. And in application layer, we are mainly extracting the query, formatting the query, and we are recognizing the intent of the query. And in data intelligence layer, we are implementing various DL models and APIs for data fetching, handles visualization, and generate insights part. And in output layer, we are mainly using various dashboards, charts, etc. for giving personalized recommendation, forecasters, and visualization. And this is our AI module architecture. I'll give you a basic flow of our model. A user is giving a user query. It is extracted by the natural language processing. We are mainly using LLM here, large language model called Gemini 2.5 Flash. And again, we fetches our market data from Y-Finance, and from the user query and the fetch data, we are giving this data into our LSTM model, and LSTM model giving a prediction. Gives the prediction, and again this prediction is sent to LLM in order to give the trend summary. And we are using this content network delivery in order to give the visualization part. And we are also trying to implement a portfolio wish list in our system. This is that I mainly explained in the graph, like user query submission, query interpretation, and then market data acquisition, prediction using LSTM, insight generation and recommendation, visualization. Mainly for visualization, we are using Plotly. And at last, we are trying to implement follow-up question sections. Like as a follow-up question, for a chatbot, there is no just we are asking one question. We can ask more than one question. Like a follow-up question, we can store the data that the user asked, and we can have comparative analysis based on this. And this LSTM is the major model that we have used in our system. And then LSTM has 3 gates. Forget gate, input gate, and output gate. This is a major working of LSTM. And then this is our major results. This is a major dashboard. We can see the market data. Market lows can be seen at the end. And then we can have the top 15 market data based on the user's interest. And at last, at the end of the screen, we can have our chatbot. We can give the query like predict the Microsoft stock for 3 days. It can give the personalized output, and then we can have the extracted data. And then these like we have LLM interaction, volatility handling, and accurate stock prediction. And this is our next for the prediction, we can have a visualized chart. We can have the predicted data and the historical data in a graphical form, where the user can easily understands the flow of stock, whether the stock is increasing or decreasing. Because the stock is something that we cannot predict. Actually, we can predict the exact value. So from this graphical output, we can simplify that whether the stock is growing up or stock is growing down. It also gives interactive visualization, textual summaries, and we are also trying to implement the portfolio management. For the portfolio, we can add whether the stocks into our wish list. It helps us to interact various stocks that we are interested in. And okay, this is the portfolio. We can add different types of portfolio. We can this is the portfolio chart of the Google stock, and we can have several periods like 1 month, 2 months, like 1 year, etc. based on our needs. And for the general framework, we are using Django for a backend, and frontend we are using HTML, Tailwind, CSS, etc. And for AI module, we are mainly using LSTM, Plotly, and other LLM-based Gemini 2.5 Flash. Okay, in comparative analysis, and as I earlier mentioned, Magnify, Stock GPT, and FinCheck AO highlight the advantages of financial systems. But we are trying to implement a dashboard which contains all the details from these systems. Like we can have a recommendation system, we can have the prediction system, we can also try to implement the visualization, the portfolio, etc. in our system. Overall, the proposed system provides a more comprehensive and intelligent framework compared to the existing AI-based investment platforms. Okay, as a conclusions, we can have various metrics called RMSE and RMSE and AA metrics in order to give more reliable and data-driven insights, which simplify the complex information for the users. Okay, we are looking forward to work more on these systems in order to give more explainable AI, better personalization, and mobile application, which further increases the usability, transparency, and overall effectiveness. That's it.
Thank you so much, ma'am, for your presentation. So, do you have any questions?
So I have a few questions. So I think towards the end, you mentioned you did some comparisons of your work with some FinChat and Stock GPT. So can you please explain how good your work was when compared to those? And what kind of metrics are you using for comparison? Like, is it speed or is it usability or
Okay,
can you please explain?
in magnifying stock GPT and FinChat, they are not interacting all these features. Okay, let me explain like this. In Magnify, they lack personalization. There is no direct interact. There is no depth analysis. And in Stock GPT, there is only limited interaction. We cannot have any follow-up question. There is only brief responses. And in FinChat, there is only limited reliable data and limited real-time response, and there is no visualization, there is no portfolio management, etc. But in our system, we try to implement more features from the system and try to implement all these system in a single dashboard, and we are also trying to implement the visualization and the portfolio.
Okay, so I think it will be good if you can add some tables in your presentation showing the comparison so that audience can catch those comparisons.
Okay, we'll try to implement.
Yes, and then another question is, so you said you are using LSTM and you mentioned some metrics such as RMSE, MAE. So did you try any other models or you just use LSTM?
We have tried using ARIMA model, but we have got more accuracy by using LSTM model, because LSTM model we can have, as I said, there is 3 gates like forget gate, input gate, and output gate, and we can fix the time period of 60 days. So in the case of stock prediction, for if the user is asking to predict the query for the next 2 days, it will take this period from the 60 days, for example, for the next 2 days and the past 58 days. That 60 days period is given to the LSTM model, and all the other data has been forgetting. So LSTM model is mainly focusing on the user, mainly focusing only on the given data, important data. So it can give more accurate answers than by using ARIMA model. So we have used also ARIMA model for the prediction, but we got more accuracy by using LSTM model.
So basically, your error scores were lesser than the ARIMA. That's what you're trying to say.
Yeah.
Okay. So in that case, also, then I think it'll be good to have some numbers showing the error scores and other metrics that you might compare, so that with numbers it is easy to compare, saying this is better than that. So that's just a suggestion.
Okay, we'll try to implement that.
Yes. Okay. Thank you. That's all I have.
Thank you.
Thank you, sir. Thank you, ma'am. Now I'd like to call upon our next presenter, Aitling Kaur ma'am, to present her paper titled Beyond Continuity, Modeling Discontinuous Risk in Altcoin Portfolios via Merton Jump Diffusion and EWMA Covariance. Ma'am, you may start presenting.
I believe that person is also not in the call.
Yeah, I assume that ma'am is also absent. In this case, we can just move on to our next presenter, Makram Dhanokar sir, to present his paper titled Bridging Linguistic Diversity, Enhancing NER Performance Through Large Language Models on Indian and Foreign Languages. Sir, you may start presenting now.
Yes, ma'am. Am I audible?
Yes, you're audible.
Okay, ma'am. So, hello everyone. So, today I'm going to talk about our research paper titled Bridging Linguistic Diversity, Enhancing NER Performance Across Indian and Foreign Languages. This work was carried out by our team at Central for Development of Advanced Computing, CDAC, Pune. Let me start with the problem we are trying to solve. Named entity recognition, or NER in short, is about identifying important things in text. Things like person name, company name, locations, events, and products. For example, if you read Rajesh Kumar works at Google in Bangalore, NER would identify Rakesh Kumar as a person, Google as an organization, Bangalore as a location. Now, this work was really well in English and other languages with a lot of training data. But for Indian languages, it's much harder. Why? Think about it. India has about 22 official languages, multiple scripts like Devanagari, Tamil, Telugu, Malayalam, and more. Each language has different grammar rules, different way of writing words. Plus, in real social media, people mix Hindi and English or Tamil and English together. All this makes NER incredibly challenging. And the biggest problem, there aren't many labeled dataset for Indian language. If you want to train a system, you need thousands of examples labeled by hand, and that's expensive and time consuming. So, let me quickly explain what NER traditionally does. The old way of doing NER is like it treats a sequence labeling task. Imagine you have a sentence Satya Kumar is the CEO of Tech India. The old system would look at each word Satya, that's a part of a person. Kumar, also a part of a system, is not an entity. The is not an entity. CEO is not an entity. Tech India, that's an organization. So it's labeling each word one by one. This approach works okay, in but it needs tons of training data for each language. The new approach we are proposing is different. Instead of labeling words, we use large language model like the same technology behind ChatGPT, and we ask them in this text who are the person, organization, and location. The LLM figure it out based on the context and reasoning. Now let's talk about why Indian languages are especially tricky. First, linguistic diversity. India has languages from different families like Indo-Aryan, Dravidian, and Tibeto-Burman. Each one has completely different grammar structure and scripts. It's not like Spanish and Portuguese, which are similar. These are fundamentally different languages. Second, complex morphology. In English, you say I go, I went, I am going. Pretty simple. In many Indian languages, words are built with a lot of prefixes and suffixes that changes meaning. A single word can mean what takes the entire sentence in English. Third, script difference. Hindi uses Devanagari script, Tamil uses Tamil script, and Telugu uses Telugu script. These are completely different ways of writing. Fourth, code mixing. This is used on social media. Someone will tweet in Hindi English mix. मेरे को ये मूवी बहुत पसंद आया. Mixing Hindi and English words in the same sentence. And finally, no label data. For English, you have millions of labeled examples, but for Hindi, maybe thousands, and for regional languages, even less. So here's what we are proposing to solve this. We call it LMRAG. That stands for Language Model Retrieval Augmented Generation. The basic idea is don't train separate system for each language. Use LLM that already understand multiple language. And instead of fine tuning on labeled data, use clever prompting. The LLM we use are open source models like Gemma 3 12 billion, Llama 3.18 billion, 5.4 14 billion. These are powerful but still small enough to run on a single GPU. Let me now explain you how the system works. So there are three parts. Part 1, embedding generation. Think of embedding as a way to convert text into numbers that captures meaning. So we take sentences in 25 Indian languages and convert them to numbers that express their meaning. Words with similar meaning get similar numbers. Part 2, storage and retrieval. We store all the numbers representation in Elasticsearch, a fast database. Uh, when a new text comes in, we find similar examples already in the system. It's like asking, show me similar sentences that I have shown you. Part 3, LLM based entity identification. We take the similar examples we found and show them to LLM as demonstration. We say, here are similar examples with entity mark. Now mark the entities in the next text the same way. All these three parts work together. The embedding help us find good example. The example guides the LLM, and the LLM makes the final decision. Now, let's discuss about the first part. We collect text from multiple sources like news, articles, official government documents, and social media posts. We use a sentence word that understand multiple languages. We feed all the text through it and convert each sentences into vector. Basically, a list of 768 numbers. Here's the magic. If you have the sentence, Narendra Modi is the Prime Minister of India, in Hindi, English, Tamil, or Marathi, they will all get similar vectors. That is, similar meaning equals to similar numbers. This is called cross-lingual representation. Part 2, Elasticsearch. Now let's discuss how we store and find this embedding quickly. We use Elasticsearch, which is a search engine that can search through millions of vectors super fast. It uses HNSW. Think of it like a super organized index where similar vectors are stored near each other. The configurations are, we use 768 dimension vectors and top five uh, top five retrieval equals to 5. So why is speed important? Because in real system, when someone enters text, we need to find similar examples in milliseconds, not seconds. Component 3, the LLM does the actual entity recognition. Here's the flow. User enters text, Raj Sharma Google में काम करता है. That is, Raj Sharma works at Google in Hindi. We convert these vectors using our embedding model. We use Elasticsearch, find five similar sentences. We get back five similar examples that already have entity marked. We create a prompt for the LLM that says, here are similar examples with entities marked. Now, mark entities in the new text the same way. The LLM reads the examples and say, okay, I understand the pattern. Now, Raj Sharma is a person, Google is an organization. So why does this work? Because we don't need thousands of labeled examples to fine tune. The example guides the LLM, reducing hallucination, works with zero shot and few shot learning. Now, prompt engineering. So we define exactly what each entity type, the person, it can be a name of an individual, a public figure, actor, athlete, or any regular person. Organization can be companies, government bodies, universities. Location is any city, state, country, or any geographical feature. Event is a sports match, election, disaster, or any named event. Product can be a brand name, movie name, or app name. Now, we add rules that say output must be in the same language as the input. So this prevents the LLM from translation. If someone writes in Tamil, we want the Tamil output. This is important because it maintains accuracy, so there is no translation error, respect the user's language, and preserves cultural context. So, handling domain variability. So, real world text is messy, especially on social media. People mix languages, use slangs, and switch scripts. So, here's what our system does. First, it
Excuse
normalizes
me,
word.
sir.
Even if
You
some,
have 1 minute to conclude your presentation.
sorry, can you please repeat?
So you have 1 more minute to conclude your presentation.
Okay, okay, then I will directly go to results. So, okay, so we use matrices like precision, recall, and F1. Precision nothing but when we say something is an entity, and we are actually right. So that's a precision. Recall is nothing but we catch most of the entities, and F1 is the overall accuracy measure. Then let me show you the results. So we have tried our approaches on different models of LLM, and these are the accuracies you can see. So here the 5414 billion has performed better compared to other because this is our understanding that 54 is better at classification task, and when it comes to generation tasks, Gemma is better. Also, mm, so the key advantages is our scalability. So you can add new languages without months of data collection. Just give it some raw text and it works. It is data efficient. That is, there is no need for thousands of labeled example. This saves times and money. Linguist accuracy, same language, same output. So there is no translation. Also, flexibility works with formal text, informal text, social media, and mixed languages. And adaptability, if the domain changes, like news to social media, the system adapts through the example it retrieves. So, if you have any questions,
Okay. So I have just one question. So, how many languages did you try at the end? And is there any language that was specifically difficult or easy to work with?
so we have actually tried it on 25 languages.
Okay.
There are languages like Assamese, then Odysseys. These are like low resource languages, so it was tough even for LLM to identify the entities there. So we tried to label more of such examples for that particular languages so that the LLM has more context and it gives better results.
Okay. So, when you say languages, I know some languages have some annotations and some scripts, the difference in script. So, will your model consider that as well?
Sorry, can you please repeat?
So, I know this English is pretty straightforward. We have A to Z alphabets, but some other languages, they might have some scripts or some extra annotations. So, does your model capture that too?
Actually, I'm not uh, able to hear you.
You're not able to hear me? So,
Yeah.
it's very simple. So, I mean, like for example, in Hindi you have ka, ke, ki. So, is your model able to capture all those three variations?
If you want, you can message me.
Okay, I'll do that. Okay, we'll, proceed to the next person.
Okay, sir. Thank you, sir, for your presentation. Now I'd like to call upon the next presenter. Small Hosna Sadika ma'am to present her paper titled Explainable Deep Learning Driven Transaction Level Customer Spending Behavior Analysis for Fraud Detection in a Big Data Framework. Ma'am, you may start presenting now.
Hello everyone. Am I audible? Hello. Hello.
Yes.
Oh, thank you.
Okay.
So I'm starting my presentation.
Yes, ma'am, you may
Hello
start.
everyone. Good morning. I'm presenting my work on explainable deep learning driven transaction level customer spending behavior analysis for fraud detection in the big data framework. My name is Asma Husni Sadika, Department of CSC from Chowet, Bangladesh, presenting in ICTIS Thailand 2026. And I'm acknowledging the contribution and assistance of my co-author, Mosharaf Hossain sir and Muhammad Shamsul Arifin sir for their assistance in our work. These are the contents of which I will discuss with you in this presentation. Now let's move on to the introduction. Sorry. In today's digital financial ecosystem, credit card transactions are generated at an enormous scale, making fraud detection both critical and challenging. Our work is on this. At first, let's see what is customer spending behavior. Customer spending behavior pattern refers to the regular and repeatable spending habits and transaction characteristics of a customer over the time. This includes several important aspects such as spending amount pattern, the time of transaction, whether it is during the day or weeknight, and the merchant categories they interact with. These patterns actually are consistent for each customer, but they vary significantly across different customers. Now, the key question is, why do we need to analyze customers' credit card transaction information? The main reason is to identify, distinguishing between normal and abnormal behavior, which will help us to detect potential fraud efficiently, especially in large-scale systems. In this work, we model customer spending behavior using a big data framework and proposed a hybrid approach that combines anomaly detection and sequence learning. This allows us to capture behavioral patterns more effectively and identify deviation that may indicate fraudulent activity. Okay. For motivation, let's consider a simple example. A customer usually makes small grocery purchase during the day, maybe $10 or $20, mostly from nearby stores. Now, suddenly at midnight, there is a transaction of $5,000 from a completely different category or location. If we look at this transaction alone, it might not immediately appear suspicious. But if we look at the customer's behavior over time, this becomes a clear anomaly. This is the key idea behind our work. Fraud is not defined by a single transaction, but by how much it deviates from normal behavior patterns. However, detecting this in real-world system is challenging because we are dealing with millions of transactions, extreme class imbalance, and continuously evolving fraud strategies. For literature review, I have studied many papers. This table summarizes the comparison of existing studies across key dimensions such as big data framework, spending, behavior analysis, predictive modeling, fraud detection, explainability. From this comparison, we can observe that most existing works on predictive modeling with limited attention to integrating customer behavior analysis and fraud detection together. So additionally, the use of big data framework is largely missing and explainability is also not consistently addressed. Overall, existing approaches are fragmented and do not provide a unified solution. To address this gap, our work proposes a comprehensive framework that integrates all of those. These are the proposed methodology. Our proposed methodology is designed for large-scale data, which will extract feature from them, and then we model them sequentially and evaluate, and the evaluation with predicted analysis with the explainability. Our proposed methodology is designed as an end-to-end scalable framework for fraud detection. We begin with multi-year transaction datasets stored in partition parquet formats within HDFS, enabling efficient and storage querying. Next, we perform feature engineering to extract transaction level, temporal, and behavioral feature. And these features are then used to construct customer level sequences, which will allow us to capture temporal dependency in spending behavior. For modeling, we employ both supervised and unsupervised model, including LSTM, CNN, and for autoencoder and autoencoder based model. Our key contribution is a hybrid approach, where the encoder first filters the most anomalous transaction and then a supervised model ranks the most likely fraud cases. This two-stage process improves detection efficiency and recall. Finally, we evaluated our models using ranking-based metrics such as PR or precision at K and recall at K. And we incorporated explainability techniques. For big data, in this work, we utilize a big data framework to efficiently manage and process large-scale transaction data. The dataset is stored in HDFS using partition parquet format, which enables efficient storage and faster data sets. Okay, Apache Drill is used for querying the data directly from distributed storage. Our dataset consists of multi-year credit card transaction with approximately 10 million records partitioned across the year 2023, 24, 25. The dataset includes a wide range of features like transaction level attributes, customer level attributes, demographic level attributes, temporal information, and behavioral indicators. For dataset validation, we compared normalized transaction amount between synthetic and real datasets, showing the strong alignment and confirmation, the realism of our generated data. And we show the I/O latency result demonstrates significant performance gains. Parquet is over 3 times faster than CSV, while partitioned parquet achieves up to 10 times speed ups. This validates both the data quality and the scalability of our big data framework. In feature engineering, as raw transaction data cannot capture fraud patterns, we extract transaction temporal and behavioral feature to model customer behavior. Behavioral features such as transaction gaps, spending changes, and rolling statistics capture how behavior evolves over time. These features are aggregated into customer-level behavior metrics to analyze distribution shift across fraud risk. We then construct fixed length sequence from ordered transaction for deep learning models. This table shows some transport customer level behavioral feature, which I have extracted from the data. In exploratory analysis, we observed that transaction activity relatively consistent across the week. With slightly variation here. In terms of channel, most of the transaction occur through point of sales, followed by online with minimal ATM usage. Spending is dominated by essential categories such as grocery, fuel, and restaurant, etc. RFM-based customer segmentation shows clear differences in spending pattern, highlighting behavioral diversity across users. Overall, these patterns confirms that customer behavior is structured and fraud can be identified as deviation from these normal patterns. Model used, our model text, we used a bidirectional LSTM with attention to capture long-term behavioral dependency and a CNN architecture to detect local transaction patterns and spikes. For anomaly detection, We employ autoencoder models such as autoencoder GRU, autoencoder CNN, where anomalies are identified based on reconstruction error. Finally, in the hybrid architecture, the autoencoder filters high-risk sequences and the supervised model ranks the most suspicious cases. We model behavior at 3 levels: sequence, anomaly, and ranking, which makes the system robust and scalable. For model evaluation,
Excuse
both
me, ma'am.
LSTM and CNN shows, yes.
Ma'am, you
I
have one
know
more
the
minute
time
to
is like
conclude your
2 minutes.
presentation. Yeah.
Yes, thank you. Both LSTM and CNN show significant performance improvement as the fraud rate increases. The CNN slightly outperforms LSTM in recall, indicating better detecting capability under higher fraud scenarios. The result shows that autoencoder-based models perform well in detecting, detecting anomalies, with AEGRU achieving the highest recall at higher fraud rates. However, the hybrid models provides the best balance between precision and recall, achieving strong performance across all fraud scenarios. Lastly, we extend our framework by incorporating explainable mechanism that quantify feature importance at the window level. For supervised CNN and LSTM, we applied gradient-based attribution, and for anomaly detection, we use reconstruction error analysis. This unified explainability integration allows the identification of key behavioral drivers influencing fraud risks across varying imbalance levels. We observed that the intersection gap here, is the most influential feature, indicating that irregular timing plays a key role in detecting fraud. In conclusion, we proposed a scalable big data framework for fraud detection by integrating customer behavior analysis with deep learning models and hybrid strategy. The hybrid model achieves highest performance in terms of peer org and recall under varying fraud rates, and XAI provides meaningful insight into behavioral patterns. However, our approach has some limitation, including the use of fixed length sequences and high computational cost. In future work, we plan to explore adaptive sequences, modeling real-time detection system, and graph-based approach to further improve robustness and scalability. These are the reference, and thank you, everyone.
Thank you, ma'am, for your
If you
presentation.
have any
Sir, do you
questions.
have any questions?
So
I have,
just
if,
okay,
Yes.
you can
okay,
go ahead. You can go ahead.
that was a great presentation. Thank you, Esmer. I have a question about the data set. You stated that you differentiate the things on time of the day and the location at the beginning, and how the system differentiate the fraud. Yes, how the system differentiate the fraud online transactions, because it's different than
I
the location
question.
or time of the
Different
day.
time and location. Actually, the data set for online transaction, this data set includes the location and time. It's a tabular data set. I cannot understand what are you saying about the all. If the all this transaction is on online, you are saying that it should not be included.
No. We have face-to-face transactions and online transactions. In the first part, you told you differentiate the data set by the location and the time of the date, and online transactions have large variation.
Here,
Maybe your results can change from face-to-face or online channel.
As it is synthetic data set, I wanted to do this as a real data set, where point of sale it was most share of transaction. So I included that. Am I getting right?
Okay. You want to go on real-time fraud detection. That's great. But on if your dataset is not great on online channel transactions, it will become a bad. It will have bad results, or it your I can see the results, but
Thank you, sir, for your questions. Kumar, sir, do you have any questions?
So just one quick question. So were there any data imbalance in your data set? So usually in fraud detection, there are class imbalance. So if so, how did you handle it?
Actually, I faced the problem of class imbalance in fraud detection. I used no, I didn't use the traditional method of evaluating them. I I have created uh, four data Farquhar format, in Farquhar format, for 2%, 5%, 10%, 12%. It's for realistic perspective. It is that the percentage in fraud rate is not more than 3 to 10%. So didn't do I didn't want to deal with the balancing method technique. I just wanted to improve the evaluation technique. So I used alert based, ranking based result, not the traditional accuracy, precision, or recall. I used an alert based 25% alert. I just collect 25% of the transaction which has more try to find out if it has more false or positive rate. Then from them I evaluated the model performance.
Okay. Okay. All right. That's all
I
I have. Thank you.
I am saying that it is the thank you so much.
Thank you, ma'am, for your presentation. Now I'd like to call upon the next presenter, Sir Christian Vera, to present his paper titled Eye Movements and Their Influence on Cognitive Processing. So you may start presenting now.
Okay. Okay. Good morning, everyone. My name is Christian Vera, and today I will be presenting my research on age movements and their influence on cognitive processing in digital assessment environments. This is my index, introduction, objective methodology, data analysis, result, discussion, and conclusion. This study analyzes the relationship between age movement and decision making in university students while solving image-based multiple choice questions in digital environments. Currently, this type of assessment which integrates image, prompts, and response options is widely used in higher education. However, there are still important gaps in understanding the cognitive processes involved during interaction with this format. In this context, age tracking technology provides a direct way to observe how visual attention is distributed, how visual and textual information is integrated, and how exploration patterns support perception, comprehension, and decision making. Additionally, from the perspective of cognitive law theory, the visual organization of the interface plays a key role in processing efficiency as it can either reduce or increase extraneous cognitive load. Therefore, this study aims to provide empirical evidence on how students allocate attention and how it is relates to response selection in a real digital assessment environment. Uh, the main objective of this study is analyze the distribution of visual attention and this relationship with answer selection in students when solving multiple choice questions supported by visual elements. An observational study was conducted with oculomotor recording during task performance. The sample consisted of 25 university students from the information system program. Select row convenience sampling under specific inclusion and exclusion criteria, such as age between 20 and 25 years, normal vision, and basic experience in web environments. Participants complete six multiple choice questions using a Google Form interface. Each item included an image, a prompt, and four response options. During the task, age movements were recorded using an age tracking device operating at a sample rate of 30 Hz, capturing fixation coordinates, fixation duration, and click events. Additionally, the data were processed to remove artifacts such as blinks and repeated clicks within short intervals were consolidated to accurately represent the decision-making action. The analysis was carried out using two main approaches. First, clustering algorithms were applied to route fixation points into areas of interest, uh, allowing the identification of regions where visual attention was concentrated. The optimal number of clusters ranged from 2 to 8 per participant, reflecting a different level of visual exploration. Second, a spatial segmentation approach was used by dividing the screen into a 3x3 grid, enabling a global analysis of attention distribution and comparison between central and peripheral regions. In addition, several metrics were computed, including time to fire fiction, total fiction, duration per area, fiction counts, transition between areas, and the proportion of pre-response fixation within the same region where the click occurred. This measure allowed use to model attention allocation, visual textual integration, and perception action coordination. The result reveals a clear and consistent uh, pattern in participants' visual behavior. Fire, First, there was a systematic concentration of fixation in the central region of the screen, where the image, prompt, and response options are located. In most cases, a single area of interest accounts for between 70% and 95% of total fixation, indicating strong attentional focus. Second, variability in visual strategy was observed as some participants exhibit more exploratory patterns, while others showed more focused behavior, reflected in the number of clusters identified. However, the most significant finding was the high level of gaze-action conflict between 18% and 95% of leaks occurred within the same area that concentrated the highest number of fixation. This indicates that decision making is strongly linked to prior visual attention, demonstrating a consistent coordination between perception and action. These findings suggest that participants control a stable spatial representation of the interface, focusing their attention on regions containing the most relevant information. This behavior is consistent with cognitive load theory, as a well-structured interface reduces extraneous cognitive load and supports efficient information processing. Furthermore, the strong overlap between gaze and click action supports the existence of visuomotor routines, where fixation on a select option processes the execution of the response. At the same time, the variability in exploration patterns indicates individual difference in cognitive strategies, which may be related to experience, familiarity with the format, or working memory usage. In conclusion, these studies demonstrated that solving image-based multiple choice question in digital environment is organized around a central focus of attention and strong coupling between perception and action. The results highlight that interface, the SIG, plays a crucial role in how a student process information and make decisions. Additionally, the studies confirms that age tracking is a valuable tool for analyzing cognitive process and improving the design of digital assessment, contributing to more efficient, transparent, and user-centered evaluation systems. Thank you.
Okay, so just a quick question. So, how do you define and identify the areas of interest or your AOIs using clustering?
Can you repeat me, please?
So, how did you define and identify your areas of interest using the clustering? So you mentioned the areas of interest, right? AOI.
Uh, I don't understand. Can you repeat me, please?
So you mentioned these areas of interest, AOI. So in your slides, you mentioned AOIs, AOIs. So if you go back to your slides, then you would see it. So can you go back to previous slides?
I use it translate because I don't understand.
Okay, that's fine. That's fine. We can move forward. Thank you.
Oh, sorry.
Thank you, sir, for your presentation. And now I'd like to call upon our next presenter, V. Abarna ma'am, to present her paper titled Hybrid Deep Learning and Quantum Approach for Multimodal Deepfake Detection. Ma'am, you may start presenting now. I'm assuming ma'am isn't present as of now, so we can move on to our next presenter. Sir Alper Ugur to present his paper titled Is Common Hardening Methods Really Sufficient? A Risk Analysis on Current ICS Vulnerabilities. Sir, you may start presenting as of now.
Hi everyone, dear chair, attendees and fellows. It's nice to be here in this international conference. This is our work with my student Emine, and I'm here to represent her with this presentation. We are going to talk about critical infrastructures such as energy, water, transportation, health infrastructures. Those are essential systems for the functioning of modern societies. The secure operation of these infrastructures of great importance, not only for the continuity of the economic or social order, but also is a national security matter. As we all know, with the rapid advancement of technology, critical infrastructures are increasingly exposed to more and more complex cyber threats. The threat landscape is no longer limited to data theft, as ransomwares, or service disruption, as denial of service, and it widens to serious damages on infrastructures and chain reactions on connected systems that disrupts industry. We looked forward to hardening mechanisms, and those are measures applied to reduce the attack surface of systems, prevent unauthorized access, and increase resilience against unexpected threats. Existing protection approaches rely on known basic hardening techniques and CVSS-based risk scoring in known databases. In this study, we examined latest ICS threats on literature and critical cases on vulnerability databases. The countermeasures and hardening methods on ICS approaches failed to fully capture modern threats. In particular, emerging attack types such as AI-driven and multi-stage attacks are often overlooked, and many threats lack proper risk evaluation. As you see in the table, most of the current threats in literature are critical threats. Those are above 9. And CVSS values are not exist in the vulnerability databases. These were uncalculated risks till now. As you see, these 4 health scores, these MVD health scores already in USA National Vulnerability Database, but the others are recent ones which don't have any risk factors calculated. Those include recent attacks and also some overtime attacks from 2017 and recent ones. We need to include the cross-layer impact affecting not only software components, but also operational technology, processes, and integrity of ICS. We done behavioral adaptability and dynamic adversarial learning characteristics. Those are acknowledged as limitations of the CVSS-based scoring approach. These findings indicate that contemporary ICS-related threats require strict hardening, segmentation, and continuous monitoring measures. Although CVSS was originally designed for evaluating static software vulnerabilities, it was adapted in this study not to approximate the exploitability and the technical impact dimensions of emerging threats, including AI-driven attacks and those scenarios. The hardening approaches are listed in some standards and frameworks, as you see on the left. For the current threats in taxonomy, the presented hardening approaches are mapped from these hardening mechanisms are mapped from Mitra attack framework and countermeasures of the source of vulnerability based on previous table, this one. In addition to traditional measures, more flexible, proactive, and intelligence-based defense approaches are required. Its adoption has become inevitable. These might become common approaches across current ICS threat protection, such as zero trust, AI-driven threat detection. The hybrid defense strategies must be utilized with continuous training and security policy updates parallel to new threats in literature. In this study, current threats and attacks targeting critical infrastructures are analyzed and their risk levels are revealed, as in risk assessment. It has shown that the current attacks score high and critical. Our results show that most modern ICS threats fall into critical severity levels, indicating that traditional hardening alone is insufficient. Among traditional hardening mechanisms, the new risks from complicated and domain-based attacks require on-point hardening treatment. We conclude that security must evolve from static hardening to adaptive and multi-layered defense strategies. We must expand the scope of ICS threat categorization, which is currently based solely on attack definition, and we did this by incorporating related hardening approaches. Instead of common measures given, we also provided related hardening mechanisms as a guide for decision makers. This study provides a more comprehensive risk perspective by extending threat classifications and introducing risk scores for previously unscored threats. Our goal is to support decision makers in prioritizing security actions. It is becoming increasingly necessary for organizations to monitor developments, calculate risk scores for threats specific to their institutions, and take appropriate measures. Thank you for your attention, and on behalf of my student, we are happy to share and glad to be here in this conference.
Thank you, sir, for your presentation. Kumar, sir, do you have any questions?
Yes, thank you. So, just one quick question. So, what type of attacks do you think pose the highest risk based on your analysis? Is it like a supply chain attack or like ransomware or something else?
Thank you. In our research, this category X and category new is the most recent attacks on the ICS systems, and the later works have these categories, and we add these two new category as must be focused attacks.
Okay. So those are AI driven attacks.
Yes, these are AI driven attacks.
Okay. So those are the new emerging type of attacks.
Yes.
Okay. Okay. Thank you.
Thank you.
Hello. Hello. Am I audible?
Yes, sir, you're audible. You can ask the question.
Yeah. Okay, so nice presentation. But what is ICS that you have written in your title? Hello. 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 He is not present.
Sir, he was trying to answer. I guess he's facing some technical issues.
Okay.
Yes, sir.
Okay, fine.
Yes, sir. We would like to move on to the next presenter. So you may stop sharing your screen. Thank you for your presentation. I would now like to call upon Nicholas, sir, to present his paper titled Time Synchronized Industrial Data Analytics for Current Unbalance Mitigation in HVAC Electric Boilers, an FMEA Guided Approach. Sir, you may start presenting now.
Okay, I will share my screen. Am I audible for everyone?
Yes, sir, it's visible.
What about my screen? My screen is what about my screen? Already shared?
Sir, your presentation is not visible.
Okay. So I'm try to stop sharing first and then I share again. Screen number. Is it?
Yes, sir, it's visible. You can start presenting.
What can my screen you see because I'm used to screen. Is my
It is
slideshow
visible.
right now?
It is visible. You can start a presentation.
In the sorry, is
It's
slideshow
visible.
right now?
It's visible to us. You can start presentation.
Okay. Good morning, everyone. Today I will present my paper about the time synchronized industrial data analytic approach for mitigating current unbalance in high voltage jet electric boiler. This work integrate multi-source synchronized data within FMEA, risk-based method to identify most significant contributor to the current unbalance and propose the practical mitigation strategy. The author of this paper is me, Nurholis, and my lecturer is Catherine Indrawati. Okay, little bit slow. My slide is changed or still number 2?
Sir, it's changed. You can continue.
Sorry, my screen not changed. Yeah, the slide number 3 is the system under study is 22 ton per hours high voltage jet electric boiler is are widely used due to their efficiency and fast response to produce the steam. However, they are very sensitive to the electrical disturbance and especially current unbalance, which can lead to the overheating, increased losses, and accelerate of the component degradation. There's some standard we rely on industrial standard rely on measurement data, terus and IEEE recommendation for acceptable current unbalance level. And the main objective of this paper is of this study is to detect and diagnose the current unbalance by combining synchronizing historical data with a structural FMEA approach. The slide number 4 is just currently changed. The plant instrumentation and data source is the boiler is heating up depend on water conductivity and stability of the conductive jet between electrodes. Steam output is regulated using the variable frequency drive controller boiler circulating pump because both of hydraulic and electrical behavior are strongly coupled, and even a small voltage unbalance around 1 to 2% can produce current unbalance up to 10%. This is highlights of importance to continuous monitoring of the boiler. The research methodology and follow the 4 key steps. Firstly, we validate the instrumentation, including class power quality measurement for voltage, measurement for measurement voltage. Second, we synchronize timestamp from the PLC historian and power quality analyzer to eliminate device drift. Third, we calculate current unbalance using RMS space current data. Lastly, we perform the processing before applying failure mode and effect analysis to identify the highest risk priority. To ensure data reliability, we apply outlier detection using AQR and Z-score methods. We normalize data to allow fair comparison across each space. Missing or invalid data point are corrected through the interpolation or selectively removed. This is clean synchronized dataset become the foundation for current unbalance calculation and later for the FMEA scoring. Current unbalance analysis. From the operational data, we observe median current unbalance about 4%. However, the maximum value reaches nearly 16%, which is significant above the typical industry threshold. Since we use the RMS current, harmonic distortion is included in the measurement. We define a warning when current unbalance exceed 5% for more than 5 minutes, and alarm when current unbalance exceed 8% for the more than a minutes. The residual current also is monitored to quantify absolute the electrical stress. Current unbalance matrix summary. Most of the operational time fall in within 3 to 5% unbalance range. However, short duration spikes, although rarely pose the highest thermal stress risk. Residual current trends to increase with an overall load, even the percentage unbalance remains stable. This confirms that both percentage and absolutely indicator are necessary for accurate diagnosis. For this reason, 1 minute data is recommended for alarm detection. Based on current unbalanced behavior, we identify 4 main components contributor is firstly the electrode unbalance, which can degrade or suffer from uneven wetting. Second, variable frequency drive control system, which may introduce the harmonic or ramp up instability. Third is power cable or termination, where loose or corroded connection. And finally, the upstream power supply, especially in case of minor voltage asymmetry. And then my next screen is still stuck. FMR, we did the FMR risk assessment following IEC 618160812, the failure mode affecting phase impedance symmetry and current distribution are enumerated for the critical subsystem. A cross-functional team assigned to identify severity, occurrence, and detection to define the risk priority number. The highest risk item involves sustained current unbalance above percent nozzle wear and machine short duration and current unbalance spike monitoring. Sorry, my slide. I have technical issue about my slide. FMS summary. The highest priority failure mode is current unbalance above 5%. And then 5% with the risk priority number of 168. The second nozzle is nozzle wear out of erosion. The based on current unbalanced behavior, we identify most of failure mode and then contribute to the problem. And conclusion, current unbalance in electric boiler generally moderate but still include source spike, then can cause significant thermal stress. The significant synchronization of measurement device is essential to accurate detect and diagnose this event. FMA approach help rank the most impactful contributor, guiding maintenance and operational improvement. Finally, implement a two-tier monitoring policy to ensure timely intervention and enhance the system reliability. Thanks for my presentation.
Thank you, sir, for your presentation. Any questions, sir?
Hello.
Hello, yes.
Yes, sir. Sir, I have just only one question. What is balance and unbalance that you have written in your presentation?
Yeah, current unbalance because we have three phase, phase A, phase B, and phase C. The unbalance is between three phase. This is if no unbalance, this have significant impact to the our system, especially in the electric boiler. That's why we have to balance the each phase the power, the current and of the each phase. This there is factor contributed to the unbalance because some nozzle wear that's asymmetry of the jet to the heating element. That's why between three phase this is cannot balance.
Okay. So what is two tire?
Excuse me.
What is the meaning of two tire?
Oh, two tire. This is monitoring of the balance, balance and current and balance. And secondly, the two tire number two.
It means you have given some bifurcation of your implementation. Like
yes,
something like in a one tire, it should be like some of the components are there. In second tire,
yes,
some other components are there.
Yeah, tire number one is about a warning. We sustain about the balance above the not more than 5% for the operational deviation. Tire two is alarm about the unbalance above the 8%. That's we implement two tires to alert the operation and maintenance, warning and alarm.
Okay, fine. Okay, I'm done.
Any question?
No, thank you, sir.
Okay, I think there are no more questions. Then I would like to proceed to the next presenter. Thank you so much, sir, for your presentation.
Okay, thank you. I'm leaving because I have to go to the Jumat pray.
Yes, sir, sure. I would now like to call upon our next presenter, Sir Sriram Dangi, to present his paper titled A Hybrid Wavelet CNN Vision Transformer Framework with Explainable AI for Medical Image Classification. Sir, you may start presenting now.
Hello. Good morning. Am I audible?
Yes, sir, you're audible. You can present. You can start presenting.
Oh. Okay. Good morning, all the respected members. So my paper is about hybrid. The title has given the hybrid wavelet CNN vision vision transformer framework with explainable AI for medical image classification. In this paper, this work, whatever I have present, a hybrid deep learning framework, which is going to combining the wavelet transformer, CNN, and vision transformer with explainable AI for the medical image classification. In my agenda, I'm going to cover the literature review, the research gap identified, the problem statement, proposed methodology, the result, conclusion, and references. In terms of abstract, this is going to address the limitation of traditional models in capturing the frequency and global features. A hybrid model is proposed and achieve the high accuracy with improved interpretability using a grad cam. In the introduction slide, here the medical image classification helps in early diseases detection and improve the patient's outcomes. AI has significantly enhanced the analysis of such images. One major challenge is extracting both spatial and frequency features effectively from the medical image. In normal traditional diagnosis, it depends on the radiologist, which is a time consuming and the prone to human error, the large data set required for the automated solutions. And here the role of deep learning, what it enables the automatic feature extraction. CNN provide high accuracy but struggle with complex medical data. By considering that point, we go with the hybrid approach, where I have combined the wavelet, CNN, and transformer. So, the goal is to improve the diagnostic accuracy, reduce the manual dependency, and enhance the model interpretability. Here, in terms of scope or in terms of this work is focused on image classification using hybrid deep learning and explainable AI techniques. As in terms of literature review, the previous work used in CNN and transforms the individually, but each has a limitation in handling the complex medical data. Though there are different models I have used, but still they have the limitation of, especially in terms of complex medical data. So the research gap, whatever the found, is to the existing model fails to capture all required features and lack of interpretability. That is the research gap what I have identified. So based on that, the problem statement define that there is need for a model that can capture spatial, frequency, and global features while being explainable for clinical use. So by considering that problem statement, we go with this proposed methodology. In terms of that diagram, you have seen that diagram. Here, the proposed model includes wavelet preprocessing, CNN feature extraction, vision transformer. So by considering all the fact, we get the good result. So here I'm going to explain the steps. First of all, get the input, the image. Then go for the wavelet decomposition. Then go for the CNN feature extraction, patch embedding, vision transformer, classification, explainable using grad cam. So that's the flow. And then after that, we got the result. You can see that show the performance here, the performance matrix. The proposal model achieves high accuracy, precision, recall, and F1 score out performing the existing methods. So as compared to this one, that this matrix shows confusions matrix shows the correct and incorrect classifications, indicating strong model performance. So then go with the conclusion. This hybrid model effectively combines the multiple techniques and achieve high accuracy with improved results. And for the references, this references support methodology and technology. I have used these kinds of different references. Thank you.
Hello.
Yes, sir.
Okay. You have given a good presentation, but I am having a couple of questions. Like you have done work on brain tumor, I think. Fine.
Yeah.
Okay. So just
Alzheimer and brain tumor.
okay. So just you have done the classification, whether the patient having brain tumor or not. Fine.
Yeah.
So why you have put the confusion matrix? Please go to the confusion matrix. Show me.
Confusion matrix.
Yeah. Now see, here you are showing like a type of MRI, brain MRI. 3 types are there, I think. Fine.
Yeah.
So this is called the multi-class classification, I think.
Confusion matrix of Alzheimer's diseases and brain tumor. Both I have shown.
Fine, I'm getting your point. But you have shown us the 3 types of MRI images.
Yeah.
Fine. But you have shown just the classification in your proposed architecture. Go with the proposed architecture.
Proposed architecture. 1 minute.
See, the output is, what is the output?
The Alzheimer's diseases.
Alzheimer and?
Yeah, Alzheimer's diseases and brain tumor types. Yeah.
Okay. So what are the types of brain tumor?
What are the
Types of brain tumor?
types of brain tumor? Here I got that I got especially primary brain tumors, Bengen tumors, non-cancerous. Basically, one is primary, in which Bengen grow slowly and which is do not spread to others. And second one is malignant tumors, cancerous, which go for the grow rapidly in terms of primary. And in terms of the secondary, metastatic, especially.
Have you gone through some other types of tumors like glioma, meningioma, pituitary? Have you heard about that?
No, sorry.
Okay, so you should study
Yeah.
these types of brain tumor classifications are there. We can say that is multi-class classification.
Okay.
Fine. So
Yes.
the tumors are also is there in a brain, glioma, meningioma, pituitary, like that.
Yes, sir.
Okay. So how you what about the novelty in your research?
What about the
Novelty in your research?
novelty? Actually, I did not get the novelty, sir.
Novelty means your contribution.
Your contribution.
Yes. The things which still have not implemented in any paper or from any authors, and just you have implemented. That is your contribution, your part.
Yeah. Okay. Just I gone through this research, read that some things and try to get these things.
No, you should know about the novelty in your research.
Okay.
Fine. So finding out from your proposed architecture and implementing your future work as a future work. Okay.
Okay, sir.
Okay, I am done, ma'am.
Okay.
Yeah, I just have one question.
Yes,
So I
sir.
think you mentioned that you're using a hybrid model, right? Over just which is, but you are not, instead of maybe like a standalone CNN or a transformer.
Yes, sir.
So what do you think is the advantage of that? So why did you go with the hybrid model?
Yeah, just whenever I go with the single model, did not get the correct accuracy. But in terms of hybrid, we got the accuracy in terms of results, especially. That's why we use the hybrid.
Okay, so is it something new that you are? So have you seen anybody else doing this? A
No,
hybrid model?
No, as my point of view, did not I have seen that.
Okay. So, I mean, to answer the other question, the professor asked, then that is something that you can say that is something that your work is contributing. That's the novelty of your work, that you haven't seen anybody using this hybrid method, but you are proposing a new hybrid method that might have higher
Yes.
accuracy or is better than the other results.
Yes.
Okay.
Yes.
Thank you.
Thank you.
Thank you, sir, for your presentation. Now I'd like to call upon the next presenter, Igling Kaur ma'am, to present her paper titled Beyond Continuity, Modeling Discontinuous Risk in Altcoin Portfolios by Overturn Jump Diffusion and EWMA Covariance. Ma'am, you may start presenting. Okay, I assume she's absent. We can move on to our last presenter, V. Aparna ma'am, to present her paper titled Hybrid Deep Learning and Quantum Approach for Multimodal Deepfake Detection. Ma'am, you may start presenting now. Ma'am, you're not clearly audible.
Hello.
Yes, ma'am, you're audible now. You can start presenting.
Okay, ma'am. Yep. My screen is visible, ma'am.
Yes, ma'am, it's visible. You can start.
Yeah, okay. Good morning, everyone. Today I am going to present my topic on hybrid deep learning and quantum learning approaches for multimodal deepfake detection. So, first, let me start with a simple question. What exactly is a deepfake? Deepfakes are AI generated fake media where person's face, eyes, or voice are manipulated using deep learning. Today, these fake videos and audio look so real that it is very difficult to tell whether they are real or fake. Now, let's see why this is a major problem. With the rapid growth of AI tools, anyone can create deepfakes easily. This leads to serious issues like spreading false information, that is, fake news, identity theft, financial fraud, and even political manipulation. So, detecting deepfakes has become very important to maintain trust in digital content. My main objective of my work is the main goal is to build a strong and reliable multimodal defect detection. Instead of looking at one type of model, I focus only on multiple types such as visual, audio, text, and even human behavioral features. Also, I use a hybrid deep learning with quantum learning approaches to improve accuracy and performance of the detection. Now I will explain the literature survey of my system. In visual-based detection, these techniques such as convolutional neural network and exception models are used. These techniques detect facial artifacts, lightning variations, and then texture inconsistencies in videos. However, they may fail when the defects is highly realistic. Next, in behavioral biometrics, the techniques such as high blinking rate, and financial landmarks analysis are used. This helps in identifying physiological inconsistency. However, but the main limitation is that the reliability is limited, especially when the fake content closely mimics the natural behavior of the person. Then moving on to the audio and speech analysis, the models like recurrent neural network, ResNet, and transformer based approach. These approach detects synthetic speech and voice cloning effectively. However, they ignore the visual information, which may reduce the overall accuracy of the model. In our audio visual method, we use the lip synchronization analysis. This approach detects mismatch between audio and video, which is a stronger indicator of manipulation. Still, they have a limited robustness under different conditions. So, overall, the literature survey literature survey state that each method focus only on single modality and has its own limitation. This highlights the need for a multimodal defect detection to achieve a better accuracy and reliability of the defect detection system. So now I will move on to the existing work. Most of the current system focuses only on single modality analysis. For example, only images are analyzed, only audios are analyzed. In visual based methods, it detects image level changes only or video level changes only, and then when come to the audio based method, it checks the voice inconsistencies, noises like that. These methods works well for simple defects, but they fail when the defects are advanced and realistic. So relying on a single modality assets is not enough for analyzing, and the performance also reduced. So to solve this problem, I proposed a multimodal defect detection framework which combines visual information, audio signals, textual information, and behavioral features such as high blinking rate and motion consistencies. This gives a more complete, better understanding and improves the detection accuracy by using hybrid deep learning with variational quantum learning classifier techniques. So this is my architecture. So first behind with the dataset collection. So here we use the standard data sets like face forensics plus DFDC and celebrity defects data sets, which contain both real and manipulated media. Next stage is pre-processing. So here where video frames are extracted, audio is separated, and text speech is converted into text. Now all these data are cleaned and normalized to ensure their consistency. Then after completing the pre-processing stage, we move on to the feature extraction stage. So in the feature extraction stage, from the video frames, we extract the features like facial expressions, facial landmarks, and movements and even actions are analyzed using convolutional neural networks. And from audio signals, we extract the features like noise, then we extract the features like pitch, sound, or speech patterns using wave to vectorizer model. And from textual data, we extract the features like stop words, transformer embeddings, and then semantic meanings using a roboto model. And from behavioral data, we analyze the high blinking rate and motion consistency of the person. Once all these features are extracted, then they are combined in the fission stage using multimodal fission. In this stage, the information that are extracted from the features such as video, audio, text, and behavioral data are integrated together. And this fused output as given to the input for variational quantum classifier. In this variational quantum classifier, that helps to identify the whether the given content is real or fake content. So finally, the system classifies the given content as real or fake. To evaluate the performance of the system, we use the metrics such as accuracy, precision, recall, FN score, and ROC curve. And for better understanding in the websites or web browsers, we are using explainability AI module to visualize the artifacts. So now coming to the conclusion part, I proposed a multimodal defect detection framework which integrates the video, audio, text, image, and behavioral features by using hybrid deep learning with variational quantum techniques. It helps in identifying whether the given content is real or fake, and it also reduces the false detection and enhances the accuracy of the model. It also performs well in real world variations or scenarios. Then now coming to the feature enhancements, Here we enhance the system using advanced quantum machine learning models, and also train the larger multimodal data sets for improved generalization, adding explainability AI for better transparency and trust in the web browsers and websites, and extending this system to real-time applications like social media monitoring. These systems are used in cybersecurity, digital forensics, and authentication systems. So with that, I conclude my presentation. Thank you for giving this wonderful opportunity. Thank you. Hello.
Yes, thank you, ma'am, for your presentation. Sir, do you have any
Yeah.
questions?
I just have a quick question. So, how does your system handle, let's say, missing or low quality modalities, like if there's no audio?
If there is no audio,
Yes.
first thing,
Is
if
it
you are
just
loading,
yeah?
if you are loading video, means from the videos, the every 30 seconds or every 20 seconds the frames are extracted, sir. From the frames, we train the model using CNN, and then sir.
So I couldn't hear what you said at the end. You got
Yeah,
cut off.
okay, sir. Once again, I say, if you are loading or uploading the video means it can, for every 30 or 20 seconds, the from the video frame videos frame image frames are extracted like images in the form of images. From the images, we identify the facial landmarks, facial expressions, and even eye blinking ratios, movement actions like that. And then this model predicts the content is real or fake, sir, instead of loading audio.
Okay, so when you say this multimodal, so are you checking audio?
Yeah, sir. Yeah.
Okay, thank you.
Yeah, thank you, sir. Any other questions, sir?
Dr. Rathod, do you have any questions? Okay, I guess no more questions. Thank you so much for your presentation, ma'am.
Okay, thank you, ma'am. Thank you very much.
So with that, all our presentations for this session have come to an end. So we would like to move towards the closing remarks. I'd like to sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of us. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We'll be happy to have you in the 12th version in 2027 as well. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Lastly, I would like to thank our session chairs, Dr. Vishnu Kumar and Professor Dr. Dushyant Singh Rathod, for chairing this session. Here is a token of appreciation to the chairs on behalf of Team ICTIS 2026 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence, respected sir. Before finally ending the session, I request you all to can you on your cameras for a quick snapshot. Can you all please on your cameras? Okay, we are finally done. I would like to end this session. Thank you so much. Stay safe and take care. You all may now leave the session. Thank you.